Hello, everyone. I'm Gianmarco Baldino. I think most of you already have seen my face. I'm presenting project 9, which is railway incident management using causal analysis. I think every one of you has faced this at some point. And it's never pleasant. Usually what happens is that if there is one delay, there will be more delays. And if you have faced something like this, to this extent, there's high chances you were in this specific part. 11% of all delays in 2025 have happened here, between Brussels South and Brussels North. There is a lot of trains every day passing through this part, and trying to figure out what is going on here could have quite an impact. So there is definitely the impact of people not being upset because they have to wait 1 hour under the rain. And this creates a nice loop of other reasons to address this problem, which include the costs related to delays and people being unhappy, fines, propagation that I mentioned, that creates this nice domino effect of delays over the whole railway infrastructure. So what we want to do, that is currently not done, is to understand what is the default approach for this type of situations right now is trying to predict if the train is going to have a delay or not, or try to quantify the delay by prediction. But what is currently missing is causal perspective, asking questions like why did it happen, why it propagated, and what if instead of this event happening, this other event would have happened, would it be any different? So what we are proposing in Project 9 is causal discovery for root cause analysis in the context of train delays. What we would like to do is 2 steps. First, build a causal graph which tells us which train was the first one to trigger the domino effect over other trains. And once we reach this point, we can use simulations, and specifically we'll use a tool named Sumo to reenact different scenarios by intervening on the root cause and see if it plays differently. So at the end of these 2 steps, we will know why specific delays are happening and what is the best action in a simulated setting to prevent them in the future. To achieve this, we use data from different platforms, mostly Inframed, which provides punctuality data for every train for every month, so it's quite detailed. We also know exactly all the geographic positions, so we can reconstruct the whole network. And additionally, for further details, there is a really nice API. It's called iRail. More in details, we will know exactly every single switch in this specific part of the network, so all the options that the train can take. We will know exactly the delays that happened in specific periods of time that we will consider. And we also can access which platforms were trains on. So we have quite a huge amount of useful data. And we plan to do this in 4 subgroups. There will be a data team that will focus on generating synthetic data that will be used for simulation, starting from the real data. So you will potentially learn how to work on synthetic data generation. There will be a simulation team Then we'll focus on the second part of the pipeline, where we need to build a simulator, put a network in the simulator, run the simulations, and interpret the results. There will be a causality team, which will take the data, process them in a way that is appropriate for performing causal discovery, check if the assumptions of causal discovery are validated and the implications of violations of those assumptions, and then use state-of-the-art methods of causal discovery on this data to try to reconstruct the causal graph. And at the end, there will be a deployment team, which will try to package all of this and give it to the community. So for now, there's two of us. There's me, more on the causality part. There's Melih from TReC, which is up there. Will also be causality simulation data. And there's a lot of spots. So if you like trains, please talk to us. More specifically, what we miss is what people from this free access, but we're pretty much open to anyone. There is a lot to do and a lot to learn from this. What we offer is a real-life problem with a company, a lot of stuff to learn, different aspects of it, and a solution that can have an actual impact. So we will try to make it first as a brick, then like paper, but this can actually become an industrial solution. And everything we learn here can be generalized to other situations that are similar, but not in the railway context. Thank you.
Thank you, Marco. Any question? Or online? I just have one small.
Yeah.
If you have access to the API with plenty of data, why do you need synthetic data?
Because the API reflects reality, and we want to create situations that are not, that didn't happen, for the what-if scenarios mostly.
Okay.
That's why we need to be able to create the synthetic data that is representative enough to reality, but if only for the what-if scenarios.
Great. Yes?
So you say you need people from the optimization field. Is it because you want to, like this what-if scenario, you want to expand a whole series of solutions and find like the best one? Is it that kind of approach to it?
Mostly yes, because the set of possible actions to take to prevent delay is massive. And how to navigate this, it's something that we currently lack.
Okay, thank you.